the center of mass will shift up. So this will set up a torque. This is a rod, rigid rod. Okay, now what is the torque? Torque about point P should be equal to mg L by 2 sine theta. This should be equal to IP into alpha. How the torque will act in this sense. So therefore minus will bring it. So mg L by 2 sine theta. What is moment of inertia of this? So this will become for small angular displacement. Time period is given by 2 pi 2L by 3g. Directly we are bringing it. So instead of something simplifying, let's have some general formula. Huh? Alpha is equal to, what is L by 2? L by 2 is a distance PC. So this I'll start from here. IP into alpha mg. This distance is what PC sine theta. So where alpha is equal to mg PC by IP for small angular displacement. So what is that PC? PC is the distance of separation between the center of mass and point P. And what is IP? Moment of inertia of that rigid body about the point of suspension P. This will, rather than this will become a generalized formula. This is applicable for any rigid body now. This will be applicable for any rigid body. Means like a point of suspension at variate as proportionally the distance PC will change, calculate the moment of inertia and work out. Okay, this will do for the best thing is we'll start with the ring, for ring or some disc. It is suspended above this point. This is a point of suspension. This is X. This is Y. So I'll display this in the XY plane. If it oscillates about Z axis, two things are there. It can oscillate about X or Z axis here. Find the time period of oscillations of the disk about X, about Z axis. We'll do the both the things. Let's see how that formula will help us find. Find the time period of oscillations of the disk. We know what is the separation between P and point of suspension and the center of mass. It is equal to R, that we know. Moment of inertia about that particular thing we should calculate here. So time period about first Z axis will go for it. That should be equal to IPZ mg. The distance is what? PC. Let's substitute all the things. 2 pi. Moment of inertia about Z axis, that should be equal to IC plus mr square mg into R. What is IC mr square by 2? Three R by 2G. What about the x-axis? X-axis should be equal to 2 pi. Moment of inertia of the disk Moment of inertia about x-axis. About any diameter. ICX plus mr squared by mg into r. 2 pi. What is ICX? Moment of inertia of the disk about diameter. This one. Should be equal to mr squared by 4 plus m into this one. About any diameter plus mr squared. This will be 5 r by 4g. I think girls will be wearing some earrings related to that. The ring can oscillate. The ring can oscillate perpendicular to plane of paper. So I think you should be very particular about the uh, axis of rotation, point of suspension. Okay, in which plane it is oscillating? See that answer matters here. Time period of about z axis. So what about this time period about? There's a disk, ma. There's a disk, no. If it were ring, okay, substitute the moment of inertia of the ring. What I'm discussing is for the disk here. If you call ring, no, then moment of inertia of the ring you bring into the picture. Now connecting rigid bodies. This is we have if we have a bob and also I'll suspend a bob here. There's a thin rod. What about time period of oscillations? This will be very troublesome students for especially for students. No, the string is having mass. Better say it has become now thin rod. What about time period of oscillation? Again, the method will be same. Just stick on to the weight of this will act mg, weight of the rod, thin rod, and the weight of the bob. As I said, it's a bob, so moment of inertia, this will become like a particle. Bob or particle both are same. This like this. So then what is the expression? M2G L sine theta plus M1G L by 2 sine theta is equal to point of suspension I naught alpha. So this will be M2G L theta L by 2 theta. Moment of inertia, what shall I write? That of the rod will be M1 L square by 3. M1 M2, sorry, this will become M2 plus M1 by 2 G by this will be one L will be here. For small angular displacement, so this will become T equal to 2 pi m2 plus m1 by 3. Now, very troublesome things, huh? You have to be very careful, huh? Small ideas. Huh? And now, instead of that bob, if it is a circular disc, what you do? Circular disc of radius r. I'm saying it will be a circular disc. This is m1, length L. Let me write clearly. This is a length. This is having radius r. This is m2. This is a disc now. Thin rod. Yeah, carry on now. So again, the method will be same. The weight m1g. I'll give small angular displacement, and the weight of this will act here. So the torque setup will be m2g L plus r sine theta, m1g plus L by 2 sine theta. That should be equal to moment of inertia of rod m1 L square by 3 plus what to do here, moment of inertia m2 r square by 2 plus m2 L plus r whole square, all set into alpha. Very moment of inertia of this whole system, that of the rod how much, m1 L square by 3, that of the disk first about its center of mass, no, m2 r square by 2 plus m2 into this distance is how much, L plus this radius r. If we mention if we mention that L very much greater than, or if we mention something like this, in that case what you should do here, you can take it r out. R negligible, here R negligible. If you put a condition, then it will become similar to, so this quantity you has to be considered here. Usually when this means again R will not be, so this will be rigid body oscillations. Solve for alpha, will get the required answer, will be very lengthy. Alpha will be, I don't think so anything can be taken, just only sine theta will come outside. In exams, they may trouble you with some data of this kind. Just be alert. G alone I'll bring outside, because that's what will be. I I think it's all about it's all about calculation of moment of inertia, no? The rigid body oscillations. Anybody having doubt, you can clarify. What happens if the pendulum is suspended about center of mass itself? What conditions will arise? If the pendulum is suspended about center of mass itself, the compound pendulum, this one, I'm suspending it about center of mass. Then, what will be the time period of oscillations? Where is the point of suspension? Exactly lies at the center of mass. Yeah, this will be. Now, what is the formula? Basic formula: T equal to 2 pi moment of inertia into mg into Pc. The point P and C both are at same point. So what is PC? PC will become 0 no here. So time period will become infinity. What do you mean by that infinity? In whichever position you keep it, it will retain that particular position. It will remain there only, it will not return back. This is some sort of like a, shall we say, neutral equilibrium. So here, the center of mass, center of gravity, if the pendulum, if a rigid body is suspended about its center of gravity, then it will be neutral equilibrium. What is C? C will become center of gravity. If the point of suspension is about center of gravity, then it's going to have the infinite time period. Infinite time period means in whichever position you keep it, it will retain that particular position. Means will not oscillate. What do you mean by infinite? Here, rigid body will not oscillate. There's a basic idea. Not only this, you can pick up any other shaped object. Here I just discussed only for this one. Any other shaped object, you can consider this one. Now, sir, if rigid body is suspended by strings, what you do? I think good question, no? Can be if the rigid body is if the rod is suspended by a string, by a strings or a string, what conditions will arise? Definitely, I think there's a very there's a rod. Hmm? Okay, there's two strings are there, so let this be length. These are the strings, and this is the length of the rod. We'll do one thing, L2, L1. We'll this having a mass, and the gravity will act here. What is the time period of oscillations of it? In XZ plane, if I define this is, find the time period of oscillations of the rod in XZ plane, means it will be twisting. Find the definitely, string is there and there's a rod. I think first we have to, how do it will oscillate? Just we'll take some reference diagram. I'll try to explain through some. There's a position of the rod will be swinging here. This way. Hope everyone is able to understand. So let me give another diagram. If it is like this, small angular displacement will be given. Rod will not oscillate in XY plane, it will oscillate in XZ plane. I don't have any other diagrams other than this. Please, you should able to imagine after this. Okay, sir, like still we are not able to. In XZ plane, the rod will rotate. A, B, C, D, let me take here. I will try to give. Okay, this is the point C. This is A. This is the beta. So slightly when it twisted, when the rod open rotated in XZ plane, this string will make in some angle. This particular string will make some angle. Okay, let that angle be beta. This is the C. Let this distance be x, and this length is L2. And the tension will act here in this direction. Let me call this T naught something. Then what about the, so like still we are not able to understand. So let me take the, this will be the position, no? This will be the rod. Regarding tension, let me show it. This is the point 2. This is the theta. This will be L1 by 2. Component of tension, how it will act? One component of tension will act here T naught sine beta will act here. And this is alpha. Say the tension will be set up here, no? T naught cos beta will act vertical. T naught sine beta will act in this direction. So this will set up a rhetoric torque. Slight given angular displacement. So what is this T naught? Initially T naught. T naught is tension. I'll write F. Some of you are getting with the time period. I'll write F. F is what? Tension. I think this will be a better idea. So what is F? 2F should be equal to mg. Let's write the equations. F equal to mg by 2. How to write the torque equations? First, shall we equate some things here? Looking at this one, this distance should be equal to x. Any relation between theta and beta. So from first equation, x equal to sine beta, x by L2, beta very small. Then from this triangle, sine theta equal to x by L1 by 2. Theta very small, sine theta. I'll bring all this. Theta very small, it will become 2x by L1. I think now we'll get the relationship between this one. What is x? X equal to L2 beta. So this will become 2L1, L2 beta. All this L1 theta equal to L1 theta by 2. Either way. Okay, this is one primary equation which I needed. Let's write the torque equation. We'll set up the restoring torque, this particular force only. And that particular force will act at both the ends of the rod, component of tension, F sine beta, here also F sine beta. This is the top viewer. These are side view. Let's write the torque equation. What about the torque equation? Torque equation will be F sine beta into, this will be L1 by 2 cos theta, 2 times, because both the forces here, no, F sine beta, here also F sine beta, about O. This should be equal to moment of inertia of the rod about O into alpha. What is F? F should be equal to mg by, let me write one more equation, no problem. This will become F sine beta L1 cos theta equal to ml square ml1 square by 2l into alpha. What to do beta? This I'll replace it. What is F? F should be equal to mg sine beta. Beta will be L1 theta by 2L2 into L1 cos theta equal to m L1 square by 12 into alpha. L1 square get eliminated. So this all together alpha will be theta very small, cos theta equal to 1. Anybody? 3g by 2l2. Only 3g by l2 into theta. Then time period of oscillations will be this replacement we have done. Sine beta will become beta. I'll do one thing. We'll write this is theta. Beta very small. If a rod and strings are there, we have to be careful. The same conditions will come. I think making observation of the system in different planes matters a lot. I'll bringing the total. This will be our answer. The rod will rotate in the xz plane. We are discussing. It cannot rotate in xy plane. If it rotates in xy plane, the strings will become loose. Here why we took it, why we took it in this way is like when you give a small twist, the tension will change. In fact, but the change will be negligible here because of two strings. I'll write that condition. F is tension the string, the tension in the string almost remains constant as the rod oscillates. It is not oscillating in some sort of like a not like a pendulum. You can see that also. Vertical force all the time has to remain constant because the see how the weight mg will act. No? So who should balance that mg all the time? It is not swinging perpendicular to plane of paper. It is in exact plane it is rotating. So the net vertical force should be equal to mg, no? And that net vertical force should be equal to tension only. So that the angles are very small. So small change in tension will come, will neglect it. I think now the rod string. So we are. I think we have just made it very things like only string we brought bob, then rigid body oscillation, then your string and the rod comes. So in which plane it is oscillating based on that. The real the rod cannot oscillate in xy plane. Some of you must know this one. Huh? It cannot oscillate. Like if you set it oscillate as it will come. Provided what happens, both the strings should become parallel. I think this question is there in SU or my if you want to do it once. It can oscillate here. Provided both the strings should remain parallel. Okay, we'll end up the class. Okay, kids, like today I just discussed about the simple pendulum and the compound pendulum. Some different types of numericals is what I took it. You check the J mains. He has given highest priority for the pendulums. Even the JE Advanced also you can take it. Some mixed concepts are there, no doubt. But when it comes to the mains or the advanced, what is the priority topic here? So definitely you can say that it's a pendulum, physical pendulum or simple pendulum. Anything related questions on this will be stressed a lot. Highest priority I'm telling. It's not about the weekend exam. Weekend exam is what I should ask the total SHM part test that one. I'm just talking about the final exam when you go for mains or advanced. The priority topic will be the pendulums. So try to think or put some effort. So any question comes will be in a better position. Then mains definitely can say there's the highest priority. Regarding pendulums, have a criteria and go to the exam. Little bit easier. Next comes kinematics of SHM. Then comes the this one damped and forced oscillations. So mains preparation I think should be very crystal clear. You must know the small topics like pendulum, kinematics of SHM, damped and forced oscillation. You need not to bother about spring block system, all XYZ. They're relevant and you can manage also anything if they ask you. Advanced you have to just gather the different types of numerical, but the priority again should be this topic. Okay, fine. Huh? So try to revise all the things. Okay, tomorrow we'll go for some mixed concept. Or I think almost 2 days we have spent it. Tomorrow let me go for SHM with the different types of systems, like a SHM with viscosity, SHM with the surface tension, SHM in electrostat. Because almost all the syllabus got over in all the topics, how that SHM's related questions will be coming.